Hello, I'm Jenny Lynch, and this is the Creative Science for Kids podcast.
Hi, I'm Matilda, and today we'll be looking at the science of light.
Let's brighten up your day with fascinating fast facts about light, a deep dive into rainbows, a question about colour blindness, some ideas about how light energy is used in technology, and a colourful activity for you to try yourself at home. Listen up, because here come 5 fun and fascinating fast facts about light.
Facts number 1. Light is a form of energy that we can sense with our eyes.
When light energy enters your eye, the light energy is absorbed by light-sensing cells in a part of the eye called the retina. The retina turns the light energy into electrical signals that go to your brain, and your brain processes the information so you can sense what you have seen.
Facts number 2. Some objects can make light.
Most of the light energy on Earth is made by the sun, and without sunlight there would be no life on Earth. Some other natural sources of light include lightning and fire and amazing luminous animals like the glowworm. Humans have also come up with ways of making light in inventions like oil lamps and candles and the electric light bulb, and more modern light sources like low-energy LED lights.
Facts number 3. Most of the objects we see with our eyes do not make their own light. These objects reflect light.
Hold up your hand and look at it. Unless you're in a very dark room or you're vision impaired, you can probably see your hand. Your hand doesn't make its own light, does it? Your hand's not glowing on its own. You can only see your hand because there is light bouncing off your hand and then going into your eyes.
Fact number 4. Light interacts with different materials in different ways. A material can be transparent, translucent, or opaque.
Examples of transparent materials are clear glass and water, and light passes through these materials. A translucent material is something that absorbs light but allows some light to pass through. For example, if you hold up a piece of thin tissue paper, you can see light passing through, but you can't see clearly through the paper. Opaque materials are the most common, and they include materials like most types of plastic or fabric, wood, stone, and metal. When light is absorbed by an opaque object, a shadow can form where the light has been blocked.
Fact number 5. Light comes in a rainbow of colours, and each colour has a different wavelength.
The sun makes white light, and the white light is made up of a mixture of all the colours of the rainbow. When we see the colours mixed together, they look like white light. If there's no light at all, we see darkness or black. When you look at a coloured object in sunlight, most of the colours of light are absorbed by the object. For example, a red object absorbs orange, yellow, green, blue, and purple colours of light, and only reflects red light.
Let's take a deep dive into the rainbow of colours that make up the light spectrum.
White light is also called visible light, and it's part of the electromagnetic spectrum. Other parts of the electromagnetic spectrum include radio waves, X-rays, and the invisible ultraviolet light, or UV, that can give you sunburn. White light is usually described as being a mixture of 7 different colours, and people use a weird-sounding word, Roy-G-Biv, to help them remember the colours. Roy-G-Biv is an acronym, and each of the letters stands for a colour. Roy-G-Biv is spelled Roygbiv. The R is for red, O is for orange, Y is for yellow, G is for green, B is for blue, I for indigo, and V is for violet.
When you see a rainbow in the sky, you are seeing the 7 Roy-G-Biv colours. If you want to draw a scientifically accurate picture of a rainbow, make sure you draw the colour red at the top of the rainbow.
A rainbow can form in the sky if the weather is just right. There has to be drops of water in the air and some gaps between the clouds to let some sunlight through. As the sunlight passes through a drop of water, the light changes direction or bends. Different colours of light bend by slightly different amounts, and that's what causes the colours in white light to spread out to form the bands of colour in a rainbow.
Now it's time for a question. What does it mean if someone is colorblind?
Most people can see colour, but not everyone sees the colours of the rainbow in the same way. A person who's colourblind will usually be able to see colour, but they might not see all 7 of the Roy-Gabiv colours. Instead of the term colourblind, it's probably more accurate to say colour deficient to describe how some colour is missing. In someone with normal colour vision, the eye has 3 different types of cells that detect colour. These are called cone cells, and they're specialised to sense either red light, green light, or blue light. There are about 6 million cone cells, and they're part of the retina in the back of the eye. If one or more of the 3 types of cone cells is missing or not working properly, a person will be colour deficient. If all 3 cone cells are missing, a person will not see any colour at all, but this only affects about 1% of people who are colourblind. For someone who's missing the red sensing cone cells, a rainbow will have lots of yellow and blue but no red. For someone who's missing the green sensing cone cells, a rainbow will be missing the green colour. The absence of blue sensing cone cells is really quite rare, and for these people the rainbow looks red and green. Along with the cone cells, there's another type of cell in the retina that detects light. These are called rods, and they sense light and dark. The rod cells work really well in low light levels, but they can't see colour. You can test this out by looking at coloured objects in a darkened room. You should notice that you can see dark and light, but everything looks grey without any clear colours. Colour vision is also best in the middle of your field of vision. You can see colours clearly in objects that are straight ahead, but objects to the side of where you're looking don't have much colour detail. That's because the centre of the retina is packed with colour detecting cone cells, and there are more rod cells to the sides.
Light is important for the sense of sight, and sunlight is vital for all life on Earth. Light is also used in a lot of technology.
In the past, people would burn candles or oil lamps to make light. Then along came the invention of the electric light bulb, which turns electrical energy into light energy. People started to understand how light energy could be turned into electrical energy, and it was Albert Einstein who first described something called the photoelectric effect, which is how solar panels work. Light energy from the sun can be collected by solar panels, which turn the light energy into electrical energy that can be either used straight away or stored in batteries to use later. Electricity generated from the sun, or solar energy, is a renewable source of energy, and it's an important alternative to burning fossil fuels to make electricity. Light can also be used to send messages over long distances very quickly. That's how a lot of data is sent over the internet. You might know that computers store information as ones and zeros. This digital information can be coded in laser light. To do this, a laser is switched on and off very quickly, so when the light is on, that stands for a 1, and when the light is off, that stands for a 0. The pulses of light are sent along a very thin piece of glass called an optical fibre, and optical fibre technology is used to send digital information all over the world.
Lasers were invented in the 1960s, and they are now used in lots of different types of technology. For example, you can find lasers in barcode scanners at the supermarket and in DVD players. And some doctors use lasers to do surgery.
I mentioned earlier that Roy-Gabiv is an acronym, and the word laser is also an acronym. The letters in laser stand for light amplification by stimulated emission of radiation. A laser amplifies one colour of light to make a narrow beam of just one colour, and the different laser colours have different uses. To make a white laser, coloured laser light has to be mixed to make white light. White light can be split into the colours of the rainbow using an old CD or DVD.
You can try this out yourself. Make sure you tell an adult what you were doing first, and check you have their permission. You will need an old CD or DVD, a torch, a piece of paper, and some coloured pencils.
Switch on the torch and use the CD or DVD to reflect the torch light onto the piece of paper. You should be able to see the Roy-Gabiv colours on the paper, but some of the colours might be missing depending on the type of torch you're using. Use the coloured pencils to record the rainbow pattern by colouring in each colour of light as best you can. This can be a bit tricky as you'll need to hold the CD or DVD in place and try to avoid making a shadow with your hand when you're colouring on the paper. The mirrored surface of a CD or DVD has lots of tiny holes and ridges. When light's reflected off different parts of the surface, some colours become brighter or darker depending on the angle of the surface. When a CD or DVD is playing, laser light reflects off the mirrored surface. Digital information is coded in the holes and ridges, and this controls how the laser light is reflected, and the information is used by the player to make the music or play the movie. It's time for us to go, but I hope today's episode has been enlightening. Thanks for listening, and remember to stay curious.
The Creative Science for Kids podcast was recorded on the traditional lands of the Bedegal people. For more information about Creative Science Australia, visit creativescience.com.au.